All right, so this here is a flue gas analyzer. All right, it uses UV or IR light absorption, and it's actually this one's a lot more simple than our first flue gas analyzer. And essentially, how this one works, right, is we have a gas in and a gas out, and right here is our IR lamp. Could also be UV as well. Just depends, right? But as the gas comes in, basically what the IR lamp is doing is it is absorbing some of the radiation. The gas is absorbing some of the radiation that is coming from the IR lamp. So let's give a random value. Let's say there is, 100 units, right, that are going from this IR lamp and going out. If there was no gas through the chamber, right, and we had the right optical filter, so depending on the wavelength of set gas, you're going to change out different optical filters, and then you have your thermopile detector, which is essentially a radiation detector. So it's going to detect the amount of radiation. So let's say we have 100 units of radiation going through the filter, right? Okay, and it's being detected here. And at the end here, if there was no gas, right, it was a complete vacuum, theoretically, we would have 100 units coming out the other side and being detected, right? Obviously, that's not the case, and the entire point is to measure gases. So, excuse me, we're going to have gas coming in, and when the gas is coming in, all right, the gas is going to start to absorb some of that radiation. And as it travels across, it's going to go through that optical filter for the specific wavelength of set gas, and it's going to be detected by the thermopile detector. And depending on how well that gas absorbs the radiation from that lamp, that's going to be less. So in this case, right now we have, some set gas going through. Usually it's most commonly used for carbon dioxide. And maybe now we get, let's say, 90 units of radiation, right? So it's detecting that change. We started out with a certain set value of radiation that the IR lamp is producing, but because the gas is absorbing it, it's not going to be detected as well by the thermopile detector because that radiation has left, right? So that's how this one works.